Okay, so we are going to do, no, it's physics 122. Physics 122. So last lesson I talked about Coulomb's force. We said that Coulomb's force, we learned about the calculations, how to this formula of Coulomb's force. I said that let me take a calculator. So the application of Coulomb force, I say that this is the constant K. The constant K, and the constant K is 9 times 10 to the power 9. 9 times 10 to the power 9. 9 times 10 to the power 9. That's the constant K. And we also talked how to find the K. We said that K is the same as 1 over E naught 4 pi. But it's not important for now. And the application of this Coulomb law, we say that this represents charge, and also this represents charge, and this is the distance. And we say that this thing is a vector. So our answer here is always positive. Our answer here is always positive. It's always positive. Although sometimes we can put a negative to show direction, but our answer should be positive because we say this is a magnitude. Magnitude means positive. Let's do a simple example. Let's assume that we have a force. We have a force there. That force is negative microcoulomb, and also have a force there, and that force is 2 microcoulomb, and is positive. And we have a force there, and that force is 6 microcoulomb and is positive. This here we are calculating the Coulomb's force. We are calculating Coulomb's force. We are calculating the Coulomb force in a linear format. Linear format whereby you involve a one axis. When I say you involve one axis, you can involve your x-axis only, or you might involve your y-axis totally. But when it's like this, your force in the second dimension, we call that a vector form. We call that a vector. We call that a vector form. We call that a vector form. So for us to calculate the Coulomb's law force there, the question will tell you that calculate the force on 2, can I either calculate the force on -4 caused by these forces. Now let us calculate the force, calculate force. Coulomb's force is the force between charges. The force on what? Which value? Choose one value. Calculate the force on. Should you choose -4, 2, or 6?
-4. -4.
-4. Which one should you choose? -4.
Yes, sir. Okay, sir.
So we need to calculate the force on -4 experienced by these charges. So there are 2 conditions. You'll be having -4 here, and I'm sorry about this line. You can just you'll be having -4 here and 2, and you'll be having -4 here and 6. So here we're going to say force on -4 due to 2. Force on -4 due to 2. We're going to say force on -4 due to 2. Here we're going to say force on -4 due to what? Due to 6. Due to 6. Then your Coulomb's law, because here the Coulomb's law is linear. It is linear. So it means you are going to add. I can say x-axis. It means x-axis, x-axis, x-axis. We don't care about direction, x-axis, x-axis. Because you don't care about the how to resolve. I know you know how to resolve. To resolve how into its y component, the x component. Like in the radical vectors, lesson number 2, yeah, Phy122. So because these things are in an x-axis, it means at the end you are going to add them. At the end, you are going to add this f -4 2 plus f -4 6. The x, so we are going to add them together. And there's no need for you to find the magnitude here because they are in. So I also know what the magnitude Leo. How similar this formula la magnitude like with the copper x and y. Yeah, I give it the millennium. So what is the formula of force on -4 2? Yeah, force on -4 due to 2 is equals to K Q -4 Q2 over the distance squared. The distance of between -4 and 2. The distance between -4 and 2. And that distance should always be in meters. The distance should always be in meters. 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 So let's, because I don't want to. Distance should always be in meters. And this is our formula. Atete is our formula. So force -4 due to 2 is our K. I said our K is always 9 times 10 to the power 9. That is always our K. Let me put it like this. It's going to be force -4 2 is going to be equals to 9 times 10 to the power 9. 10 to the power 9. What is our Q4? Our Q -4 is going to be -4 micro. That thing means micro. And micro is times 10 -6. But there is no need for you to put this -4. Just remove the negative there. Because like I said, this thing is a magnitude. Our answer should always be positive. So no need to put the -4, just put a +4. Even now, multiplied by force A2 is 2 times 10 -6. 2 times 10 -6 over the distance squared. Let's assume that the distance here is 2 meters. 2 meters, and the distance here is 3 meters. So distance here is 2 meters. Distance here is 3 meters. So they may ask you, these guys, they can give you a charge and a charge. So our value there is going to be 2 squared. 2 squared. I think we say that it is r squared, the distance between. So it's going to be 2 squared. This distance is always in meters. When you are given it in centimeters, you make sure that you convert it to meters. So you may take your calculator there and press. Let us press 9 times 10 to the power 9 times 4 times 10 to the power -6 times 2 times 10 to the power -6. You get that divided by 4. So our force there is 0.018 Newton. Because these are Can you switch off your mic? Hey, there's a question you have to ask.
ne ka tlo botsa gore tsa ka e two squares.
He's asking where we got our 2 squared. I said that the distance between these force which are dealing with, the distance between -4 and 2 is 2 meters. So the formula says that you take the distance, which is r, which is 2, and we square it. So these 2 meters were given in the question that the distance between -4 and 2 is 2 meters. Is 2 meters. So we calculated and our answer was 0.018. 0.018. So we go on and find the force on -4 due to 6. Force on -4 due to 6 is going to be 9 times 10 to the power 9 multiplied by force is -4. So you have 4 times 10 -6. I think I have -4. I add a negative because your answer is going to be positive. So it's going to be 4 times 10 -6 times 2 times 10 negatives. Not 2. It's 6. It's 6. So this paper this is over. The distance between -4 and 6 is 3 meters from the question. Distance between -4 and 6 is 3 meters. The distance between -2 and 6. I mean, -4 and 6 is 5. I get 2 plus 3. 2 plus 3 be 5. I agree. Go tswa ha go ema ha ke 2. Go tswa mo -4 ya go +6. Ha ke ye plus ye, so ya go nna 5. So I've made a mistake here. It's going to be 5 meters. So these 5 meters are going to square it. You're going to say 5, which is the distance, squared. And this distance should always be in meters. When you are given it into centimeter, you convert it into meters. When you are given this distance in centimeter, you convert it into meters. So you are going to press a calculator there. Let me tell you something. I encourage you to press the calculator because it will be your first time to deal with these things. Say. Press. Most of you will get this right, but your question will be wrong. If you don't practice multiply because there might be many sometimes. Nine times 10 to the power negative, 9 times 10 to the power 9 times 4 times 10 to the power negative 6 times 6 times 10 to the power negative 6 divided by 25. Even now 0.00864. 0.0864 Newton. 0.08. Okay, now it's okay. Now 0.0864 Newton. Then you add these guys. 0.0864 plus 0.018184. Even now your answer there. After you add this and this, your answer is going to be 0.02704 Newton. Agree, this is your answer. Then you press second function, setup 0 scientific. So your answer is going to be 2.7 times 10 negative 2 Newton. So we are done now in calculating. A Coulomb's law in a linear form. So let me start by explaining it again for the sake of those who just arrived late. I said that Coulomb's calculation of Coulomb's law. These are formula as we said on our last lesson that this, in this our formula, this K is 9.9, 9 times 10 to the power 9, and this is the charge with the two charges, and this is the distance squared. This is the distance between the charges. So we just formulated the equation here and say this charge is negative 4 microcoulomb. This is positive 2. This is positive 2. This is positive 2 microcoulomb, and this is 6 microcoulomb. So we are having them like this, having them like this. So what we're going to do now is our question was to calculate the force on negative 4 charge. To calculate the force on negative 4 charge. So as calculating the force on negative 4 microcoulomb, it is our negative charge. So the question can say, calculate the force on the negative charge. And there's only one negative charge there. So what we're going to do is to write negative 4 to 2, and we look at the distance between negative 4 and 2. And we write negative 4 to 6. And the distance between negative 4 and 6 it is 5, because we're going to add these meters and add these 3 meters, and you get this 5. Get this 5. Now we are going to say force on negative 4 due to 2, because is any x is just like x. Force on negative 4 due to 2. Force on negative 4 due to 2. It is force on negative 4 due to 2 is K Q negative 4 charge negative 4 charge 2 over the distance squared. So we calculated it, and our calculations were here. We said that charge of negative 4 due to 2, the distance is 2 squared. We saw this. In which force on negative 4 due to 6, here, this is the distance between them. After that, we add this and this. After adding that and that, we got this. We got this. We are done on calculating this in linear form. So the exercise here, exercise number one is exercise one. Is we are going to calculate. Most of you don't submit my exercises. Hey, and it's a far distance. So after this lesson, I'll be marking your all the exercises which you can use minutes after. Because of biology, there are many essays which I need to read. And I will just give you a feedback individually, WhatsApp. So you're going to calculate force on, choose which charge. Apart from -4, choose another charges. Which charge? You're going to calculate force on which charge? You choose one charge. Choose. You're going to calculate force on which charge? It's okay. Calculate force on this charge plus 2 microcoulomb, where this distance here is 3 meters. Here is 2 meters. This is the exercise of today. You will write it and submit it. Are we together? Yes, Ronald.
Good morning. Kopa botsa ka kgang ya negative. That last lesson in what negative ga tsene mo di calculation mo super direction kana ga ka utlwa sentle.
Yeah, negative. You see, this sign means magnitude.
Yes.
So negative kana tsena kana sika tsena, your answer should always be positive because it is magnitude.
Okay.
Yeah. So kana o tsentsa gona molato me o itse answer ya go ha kana negative ya gona positive because of to respect this side.
Yes.
Of magnitude. Yes.
Thank you.
So yeah, you're welcome, Mr. Ronald. So this is the question which I want you guys to be doing. So we are going to do it like it's linear. Like, don't bother about the y-axis. Why? Because like this, just linear. So now, let us do the vector form. Where now we have to write a force in some vectors. Write a force in some vectors. It's called the vector form. So I want you guys to remember what you learned this year in terms of vectors. I want to also to simulate 1222 early physics. Hotel biology. Semester 2. You like high school level semester 1, so you can just reference over but I was doing like this. So next year, most of you should have that is elevated because of the pressure and all this kind of. So the vector form of a force. So I gave you a question. I said you need to write it down in your books. This is the question which I gave. So this can come into two formats. They can draw a figure like we have drawn a figure, or they don't draw a figure like question number 2. I didn't draw a figure. I just expected you to draw a figure. So this question is so simple. And I like it when it's in a vector form, these columns, because when it is on a vector form, is so simple. So let's study our diagram. Our diagram, we have charge there, we have charge there, we have charge there. So this distance is centimeter. automatically it is telling us zero. Penyo zero. Penyo, you raise up your hand. Do you have a question, sir? Okay, no, you will ask. Now, let us study our diagram. This is our diagram. So this is centimeter. It means we have to convert this to meters. We have to convert this to meters. That's a must. This is also centimeters. So Q1 there is 4 microcoulomb. Q2 there is negative microcoulomb. And Q3 there is positive 2 microcoulomb. So the question says, from the figure, calculate the magnitude and the direction of the coulombs. Calculate from the figure, calculate the magnitude and direction of the coulombs force on a negative charge. From the figure, calculate magnitude and direction of the coulombs force on a negative charge. The negative charge is at Q2. So you need to calculate the coulombs force acting on Q2, meaning that for us to calculate the coulombs force acting on Q2, let us look at our, I want you to pay attention here. It means this force is positive, this force is negative, and this force is what? Positive. So calculate the direction and the direct magnitude and direction of the coulombs force on a negative charge. So this are linear. But now it is in two directions. It is in what? Two directions. It involves the x-axis and also involves the y-axis. We said that half force in Tiana, force hectare engwe hectare yana, jaka engwe hectare yana, engwe be hectare ibe hectare yana. We say that rebata inkana, rebata magnitude. Magnitude kimtaka. Lantalo hanya.
Yes.
Okay. Even those who are quiet, I hope they understand. Hey, Penyo Tsibu. Tsibu. So we said that when a force is acting like this and like this, the magnitude is this one, which is, we like to call it a resultant. But why did I choose to draw the arrow like this? I drew this arrow like that because when we have a negative charge and a positive charge, the negative charge attracts a positive charge. I'm not doing it. Yes, this also, I can draw it like this, but my answer, my question demanded me to put this as a center of attraction. That's why it is on a negative charge. Calculate a force on Q1. Because this was my center of attraction. Like the question demands us to be using this guy. Ngawe supile kwa. Ibeta isupa kwa. Let me teach you how to draw these arrows. See, one of the people calculate force on a negative charge. The question demands us to calculate a force on a negative charge. This is negative charge. So negative charge is our center So it's on this force. This arrow goes like there because when we have a positive charge and negative charge, there is attraction. Now, if you have a negative charge and a positive charge, there is also attraction. So this is our result then. This question, we can say force on charge 1. When we say force on charge 1, our arrows will be like this. This attracts to this. This and this, they are positive. What do? They repel. So our arrows would be like that. Would go there because this and these are going to repel. And we'll go there. Go there, repel, go there, attract. You do a question where it deals with the repulsion when time goes on. But now, our diagram is this one. So here, what I'm going to do is, this side is force. Okay. This side is force on 2 due to 1. This side is force on 2 due to 3. So you have force on 2 due to 1. And this force and 2 due to 1, you are going to write it in x, comma, plus y. And this 4 into 2 due to 3, you're going to write it into x plus y. But because we can see that force on 2 due to 1 is just a linear. It means mthaka y. It's just linear. So here we just cancel our y. You know that there's no y. When you look force on 2 due to 3, it's just a y. Hana x. Hana x. Hana x. So we can just cancel the x. But at the end, when you add this force, I mean the magnitude of this force and the magnitude of this force should give you what? This force. Let's call it force magnitude. Force M. You know, this thing was acting at an angle. This force 2-1, force 2-3. It's x and y. So after here, we add our x again. Was here y is 0. Here x is 0. So after that, we add our x, we add our y, we calculate the magnitude, and magnitude came taga. So force due to 1 is 9 times 10 to the power 9 times charge number 1. Charge number 1 there it was 4 times 10 negative 6 times charge number 2 it was 3 times 10 negative 6. 3 times 10 negative 6 over. So the distance there, the distance between Q1 and Q2, you can see that it is 5 centimeter. Is 5 centimeter from the distance ya go tswa ha go ema ha. Re kgona bona re ke 5 centimeter. La bona re ke 5 centimeter again. So it means ya go na 5 times 10 negative 2. I can convert that to meters squared. But this is the only force. It is F21x. F21x. Mind you, this F21 hana y-axis. That's why you can say y equal to 0. Force 2, 3 hana the x-axis. That's why you can say hana. But sometimes one. So you are going to get an answer here. You're going to write your answer, which is neutral. Then what you're going to do next is you're going to say force 2, 3, y. Why? Because the force 2, 3, its x is what? Is 0. So what 9 times 10 to the power 9 times force on 2 is 3 times 10 negative 6. Force on 3 is 2 times 10 negative 6 over Q3 Q3 is 2, so you call it 2 our Q2 is the center, so you need to thing here always Q2 to thing here. Q2 to everything here. What is this distance? 3 centimeters. So it's going to be 3 times 10 negative 2 squared. Then what you're going to do is to calculate this value there and calculate this value there. Let us calculate these values. Someone just calculate this value here of force on 2, 1. And someone calculate the value of force on 2, 3. Please just calculate. And you tell us the answer. So it's going to be 9 times 10 to the power 9. To the power 9 times 4 times 4 times 10 to the power negative 6 times 3 times 10 to the power negative 6 divided by brackets of 5 times 10 to the power negative 2 negative 2. It's going to be 2.16. No, this is not the answer. Peter?
Hey, say, I have a question. How go force 2 due to 1? You wrote, I thinking 9 times 10 to the power 9, I get it times 4 times 10 to the power negative 6. Ke batla go botsa gore why re kwadile 4 le 3 instead of 2 and 1. Like, where did you get the 4 and 3?
Hey, I don't want to. These are the charges. Charge Q1, Q4.
Oh, yeah.
Hey, charge
Thank you.
yeah. Hey, Q2 key. I want to play answer. Like, times 9 times 7. You have raised up your hand even today. Okay. Yes, yeah, physics. Divided by makes sense, right? 9 times 10 to the power 9 times 4 times 10 to the power -6 times 3 times 10 to the power -6. And so here I get something like 43.2 Newton. And in some of your, they might write it negative, meaning that the negative just showing that iyakwa. But especially akuntsana negative kwa negative. Mira ema ke tsenye mthakayo. Yo. Ema ke tsenye mthakayo. So I can mthakayo, my answer is correct. So let us calculate the next one. People are not calculating because I was waiting answers from you, and I just keeping quiet because I need to see whether you can use a calculator here. Because most people they fail in these questions because of the ability to be able to use a calculator. But you don't want to show me that you know how to use a calculator. It means you don't know how to use a calculator. It's simple. So here's going to be 60 newtons. So I have this force. Now, when I write force on 2-1, I should write it as 43.2 Newton on the X plus 0 Newton on the Y. And here I just write 0 Newton on the X plus 60 Newton on the Y. Yeah? We don't hear you. We don't hear you.
Nekiri ke bone 7 gateng is 1.728.
On which one?
Ile ya ntlha e godimo e.
No, you didn't press well the calculator.
Ke
Then I
calculate
like keep press ahead.
you know rank 43.2. Ke bone 1.728.
No, you didn't press well the calculator. I'm telling you, Mr. Theo. Didn't press. So then the first time I calculated it, I saw a number which was not good. And I said, let me just do it again. So I did it 3 times to cross-check. But this is the answer. I hope most of you saw this one. Or others didn't calculate. Silence means people didn't calculate, but it's not good.
I went 43.2 newtons.
Okay, that's good. That's good. So 421 you can present it like this, and 423 can present it like this. I agree. We didn't have the X part and the Y part. Now we have now our F21, which it was F21. It is in the X of 0 Newton. I mean 43.2 Newton. 43.2 Newton. And it is in the X again. So plus 0 Y Newton. and also we have force 2, 3, which we have 0 Newton X plus what 60. So some of you, these numbers to you, you can just put a negative showing that it goes to this direction. Here goes to this. Here you can put a negative, 61 negative. So Baba, you can present it like this: negative 43.2 Newton X plus 0 Newton. Or 0 Newton X minus 60 Newton Y. You can just present it like that, showing that this guy goes down. So this guy goes to that side. This guy goes down, negative 60 goes there. It's 43 point. But because we put it as a form of a magnitude of 2, 3, so magnitude of 2yx. So even 43.2 Newton. Even magnitude of 2, 3y, even 60 Newton. So now we don't even care with here. We don't care with the. We said the x. We don't care with the y because said the x. Here you don't care with the x because said the y. So even nine. So now this force, force magnitude. Because the question says you calculate the magnitude. So this force magnitude, it is one force magnitude. 9 force magnitude. 43.2 squared plus 60 what squared. Again, so your answer there is it is this force, the resultant force. I hope you'll take it vector, right, guys? I hope you're understanding better this time, because these are just is repetition at a vector. Silence means people don't understand. So 43.2 squared plus 60 squared. Square root of that, we have 73.9 Newton. And this is our magnitude. And we know that for us to find the angle, we always say this over that, this over that, this over that. So our angle there theta is tan theta is 60 over 43.2, which is our tan theta. 60 over 43.2 is going to be inverse or tan inverse of tan. 60 divided by 43.2. Even 54.2, even 54.2 degrees. Therefore, our magnitude is 73.9 Newton at 54.2 degrees. And you get your 10 marks. And in this physics, there's what's called tutorials. Tutorials will be going at the labs to write one question. We'll be going during lab time when other people are in lab. We're not about a single question. And the people so they take it address it say we're going to do them on labs. Especially all these questions which I address them here, are going to do them on labs. And it is better to pass tutorials because they're going to boost your CA. Because chances are high that next year you will also be like other people of other faculties of 40% CA. And 40% CA guys, so this is our answer. This is our answer. So I hope these things are simple. I didn't hear a voice of Josego even today. Josego, are you good? Josego Silene. That's good. Now, let us redraw these things again. So this question I want you to do it as an exercise 2. So I want to see something. But I'm going to address such a question here using that first guide. It was like this. So if for I wanna that I wanna like it's a sharp. So mtaka nearly 0, 1, 2, 3, 4, 5. Okay. Eish. Tagalo kaya no sa ubo. 5 3. I'm just drawing this guy again. Nearly Q1 again. Q1 nearly 4 microcoulomb. Ako mga bata na. Ako na ansalo ko na nearly Q2. So Q2 ako na H. Q2 ako na nearly -3 microcoulomb. Yung bata na gawin na Q3. So Q3 ako na bata na 2 microcoulomb. So now we are going to find the magnitude. So for us to find the magnitude on force, actually on charge 3. This is our charge 3. Now you are going to find the magnitude on this charge of this guy. So for us to find the magnitude of this charge on this guy, so this force is positive, this force is negative, and this force is what? And this force is positive. This guy is a reference. This guy to this guy, there is attraction. There is attraction. Like when I get attraction, I think. I hope like ball. So I is the positive, this positive. So there is repulsion. There is repulsion. So the repulsion I guess I'm yo pushayo or yo aye kwa yo pushayo or yo aye kwa yo aba pusha or yo aye. There's repulsion. So how can say guys? We can see that our magnitude will be this force here. That will be our magnitude. That will be our magnitude. So that's the force I will push. It's similar. Force I will push. It's similar. Me, you transfer ya. Like this force that we push anan. Yellow ni push anan. So we have 2 arrows here. So let me draw this charge here. This is charge Q number 3. Again, this charge, it has a force going there. It's charge Q number 3. It has a force going there, and it also has a force which is goes there. So this force which is going there, it is force on charge number 3 due to charge number 2, which is this force, which is force on charge number 2. I mean charge number 3 due to charge number 2. Like force yanko. So force yanko tasi ye is the force on charge number 3 due to charge number 1. So it means force on charge number 3 due to charge number 1. Ladies and gentlemen, how on tsana? Kona mona nthakayo. Nthakayo kone yo. Ikila 90 degrees again. Amon. Aba khala mo half ya 90. It means mthakayo ki 45 degrees. So mthakayo le 45 degrees. It means mthakayo kone kayo. If 45 degrees le nga o khala mo half ya 90 degrees. Angles. Bago ya kona 45 degrees ka. O khala mo mthakeng. I hope we are together. So angle 45. So yeah, force. I want to listen to that. So this on force on 3-2. Force on 3-2. It's going to be force on 3-2. Why only? Why? Because we see that this force, not the x-axis. This force, because it's not acting at it is acting at angle 90. Not acting, it's not oblique, it's not acting at an angle like ye actor at 45. Mean that in Takayo, usaja ka wakantilo yuli, uneki y hela. So raho plaka in hela, replaka in hela. Very times times Q3 here, times Q1 here. Times Q2. I'm going to say times Q3 times Q2 over the distance squared. So the distance aruna mthakayo. Yeah, go tswaha. Oyemaha. Distance go tswaha. Oyemaha. Ki 3 times 10 negative 2 squared. Again. Then the force on 3-2. Force on 3-2 about the magnitude of force on 3-2. Pili. Rebatam takao pili yo pili yo. Rebatam takao pili yo. Use out the magnitude of 3-2 yo. Raho watayana times charge 3 times charge 1 over distance squared over r squared. Hansi na go batam thakayo le magnitude. Ra go tsaya magnitude, re kwala magnitude yo. Ra go kwala magnitude yo in terms of cos theta le sin theta. I hope you understand. Ra go batam thakayo le magnitude like we are doing in vectors. Then after we find this guy, which is the magnitude, ra go kwala this guy in terms of x-axis and y-axis. Lanswa, lantalokai. So for this guy, okay. I was saying that this force 3-2, we are going to find the magnitude of force 3-2. Then, after we find the magnitude of force 3-2, we are going to write force 3-2 in terms of x-axis and y-axis. We are going to write the force 3-2 in terms of x-axis and y-axis. So let us find the magnitude then. So the distance, we are going to look at this distance. This distance, it should be the same as this distance. This one. So we are going to use the Pythagoras theorem to find this distance here, to find this hypothesis. Because here we have 5 centimeter, we have 5 centimeter, we have 3 centimeter. Distance here is the same as this distance. So we are going to find because first ye ke yone re tshwantseng ga ke boletse gore go itshwantsha because go no go sa make sense re ka itshwantsetsa because I will confuse so go itshwantsetsa kae ha. So for us to find this distance ya go nna 3 squared 5 squared 3 squared plus 5 squared square root when 5.83 mean that this distance here ya gonna 9 times 10 to the power 9 times charge 3 is 2 times 10 negative 6 charge 1 is 4 times 10 negative 6 over 5.8 5.83 is 5.83 centimeters. So we are going to divide by what? By 100. Again, 0.0583, which we are going to square it. Going to square it. Mind you, this is charge Q3 is there because it's our reference. Charge Q1 is there. This distance, how did we find this distance? We found this distance using the Pythagoras theorem and say this distance here is the same as this distance. So we calculate this one using the Pythagoras theorem. This is 3 centimeter, 5 centimeter. After we calculated using centimeters, we convert the answer to meters because this is the meters. The value of the force which you are going to get here, it is this guy. You. So if I press my calculator well there, 9 times 10 to the power 9 times 2 times 10 to the power negative 6 times 4 times 10 to the power negative 6 is equal to that divided by 0.0583 times 0.0583. I'm going to get my answer is 21.2 Newton. Ladies and gentlemen, this 21.2 Newton is this guy, this one, you get 21.2 Newton. So this guy, 21.2 Newton, what are this guy in terms of in terms of x-axis and y-axis? So let us calculate this guy first. You were force of 32, force of 32y. Make it a guy, or a kibukai. And now, how come in the form of x and y? What the y-axis is here? I acted in any angle. Although some books they can say who acted at cost, and I think cost 9, I think cost 9. Yeah, so this guy who acted at cost 9 in the x-axis, that's why I see. But you understand better when you are doing trigonometry. But now I want to use a basic skills last year. I mean, that's this year, such vectors. So this guy up on 9 times 10 to the power 9 times Q3 there is Q3 is this one again. 2 times 10 power 86 times Q2 is our Q2 is 3, is negative 3. So it's going to be 3 times 10 to the power negative 6 divided by 0.0, this times 0.0. Mind you, don't forget to convert that distance into meters. So our answer here is 60 Newton. Answer there is 60 Newton. So let me write to this page. I have the force 3 2, which is 0x Newton plus 60y Newton. Ra dumalana ke thakayo yo. Ra dumalana thakayo ntsiana ke yo. Because ha kana le x ka o vertically. Besa le mthakayo bitso di f3 on 1. Mthakayo f on 3 on 1 yo. Untsiana. But we want untsana. Khathi mthakayo ke 21.2 Newton. So angle ke 45 degrees. So ra go bata the x component wa mthakayo. Be re bata the y component wa mthakayo. So the x component gona bona ke cos. I hope you know how to find the x component. Ki x ke onetse ye le. So ke onetse cos theta, onetse cos. Unetse cos ke onetse ye le adjacent side. I don't know that cos is equal to a over h. Is a over h, which means that how about a you are a is equal to h cos theta. What is our h then? Our h is this guy. So this guy, we need to write this guy into x and y components. So our x component, what this guy, f31, which is our h again, cos theta. F31 is 21.2 cos 45 x Newton, which gives us 21.2 cos 45 is 15.0 x Newton. So which is our y component of this guy, y component of this guy. Sine theta is equal to O over h. Again, O over h. So h sine theta. So O h sine theta. So our h is f31. I think our h is f31 sine theta. Sine theta. F31 is 21.2 sine 45, which gives us y Newton, which gives us 21.2 sine 45, which is also 15.0 y Newton. That's a coincidence. It's not always like that. So my force F31 is the same as 15.0 x Newton plus 15.0 y Newton. What are you going to do? We are going to add the x's of this guy and this guy. We're going to say, now for us to find this magnitude, this magnitude, or this magnitude, I know the vector I didn't pay. Can I hear we're adding vector I, the vector I? For adding vectors, we add what? Vectors we add what? We have a new vector now. That new vector, I'm going to say 15 plus 0, 15 x Newton plus what are it? 15 plus 60. 15 plus 60, 75 y Newton. 75 y Newton. Then we have 15 squared plus 75 squared. For you to find what? The new magnitude of that new force, which is 15 squared. 15 squared. 15 squared.
Can you repeat why you used 75?
This 75 is, actually, I'm saying that I'm going to add the vector of F31 and the F32. I'm adding components. 15 plus 0, even a 50 x. 15 is 0. After that, I'm going to say 60 plus 15. so that I have 75. You understand? I'm adding vectors. I'm adding this vector. I'm adding vector. I'm adding vector 3, 2 plus vector 3, 1. When you add the vector, yeah, when you add the vectors, you take the x component, and then you add the x component first. Then after you add the x component, you then add what? The y component. Like here. I add the y component over the magnitude. So how let's now add this vector. Let him say it is vector 3, 1, 3, 2. Vector 3, 1, 3, 2. Again, the 215x Newton plus 25y Newton. So it's now the add. This is a new vector. I find the magnitude. After I find the magnitude, my magnitude there is going to be 76.5 Newton. That's the magnitude of these new vectors. How to over the angle of 20? Put the vectors. I had one magnitude there, and I put over the angle. So the angle this one over this one. Again, angle this one over this one. Because when I'm calculating this angle, I'm going to have theta is equal to tan inverse of 75 over 15, which gives us second inverse of tan 75 divided by 15, which gives us 78.7 degrees. So our answer is 76.5 Newton at 78.7 degrees. That's our answer. That's our answer. So what we need to do here is we need to make sure that when you present your vectors, you draw. This is the sketch. This force and this force, these attract to this force. It is linear in the y-axis. So we just calculate it once. And because you calculate it once, we know that it does not have an x value because it was in the y-axis. This force is just is in the y-axis. So that we calculate it once. So you know how we resolve it. How we equal to although we equal to the x component and y, but it's the y component. X component like 0. First is acting at an angle. By one of the forces is acting at an angle. So first year what a magnitude of Takayo Pili, your magnitude of Takayo. Magnitude of Takayo Mata Yana. These are Coulombs law. Please, now Coulombs law. Before you calculate this Coulombs law, we call a formula like Coulombs law called Dimupi. So 2 yoki force ye force ye force. So distance you ye ribatile yana. Reduce Pythagoras theorem ya. There was that distance I'm taka. Very so distance I'm taka is the same as distance I'm taka. Same as distance I'm taka. There is never that. There about I'm taka. Has not I'm taka 21.2. Taka 21.2 kiyo rematile kiyo. So sonto kalam taka into x component and y component. So here never kalam taka into x component. The other kalam taka into what? Y component. Always. After that, I'll add the vector. I'll add the vector 3, 1, 3, 2. So add the vector. What's our x? Yaka 3, 2. We add the x yaka 3, 1. One the vector right addition. What's our x yaka 3, 3, 2. We add y yaka 3, 2. We add the y yaka 3, 1. One takai. What a magnitude on tagai, who square what's in your brackets in. What a angle at all. Angle to ye over, Kimura Kitan, ye over. What the present will be done and dusted. and ready to pass. Any questions before I end the lesson? And the remainder is, this is the exercise that you're going to write. This is the exercise which you're going to write. I sent it, Harry. And another exercise which you're going to write is this one. Another exercise which you're going to write is something like, I gave an exercise card. A key. This is another exercise. I'll take a photo and I'll send it. So you are good. And now you can begin to attempt questions on MC1. I sent it. You can begin to attempt question on MC1. I sent it. But after here, I'll be marking. I'll be busy marking your bio, your chemistry. So most of you, I know you want these recordings. Okay, let me do like this. After here, let me go to and go and upload them. Let me go and upload them. I'll go and upload them. But it will take maybe 1 hour, 2 hours to upload it. Hey, because internet the internet upload. Thank you very much for listening. You can ask me questions.
Sir,